Hello friends, so once again welcome to my channel, and in this video we will see another one more algo for doing the division of positive integers. The name of the algo is non-restoring division algo. So see, in the last video we have seen restoring division. In case of restoring division, whenever the sign bit of a that is 1, that means we are getting a negative value after a subtraction operation. Then what we used to do? We used to perform what? A plus m. We add m back to a. This we used to do. And after that, what we do? We perform your left shift operation. That means we will do multiplication by 2. Shifting to the left is equivalent to multiplying by 2. And then we perform the subtraction. So this become minus m. So see, if I break it, this is twice a plus twice m minus m. What I can write? Twice a plus m. So here what I would like to conclude is, instead of doing your that restoring part, whenever we are in the beginning itself, if we are having a negative your this one, what is that value in a, then we will perform your left shift and we will add m. We'll change the algo. So whatever I have said, I'll show you here. In case of restoring division, after unsuccessful division, m is added to a, then shifted to the left, and m is subtracted from it. This is the sequence of events that takes place. So a plus m, then we will shift it, then we'll subtract m. This is nothing but twice a plus m. So what we can do, shift a to the left and add m directly to it. No need to perform subtraction, then addition, then again the repetition. So directly we will do twice a plus m, right? So this only we are going to do in this non-restoring. That means that add m back to a, that part is not there after a subtraction operation, right? That part we are going to remove. So it will take lesser time, right? So see here, in non-restoring division, a will be taken as 0. How many bits? Whatever is the number of bits in my operand. Q will be having dividend, m will be divisor, n is number of bits in the operand. Now see, again I will tell, dividend and divisor will be represented using equal number of bits. And one extra bit is taken in A to keep track of the sign of the result of your operation that you have performed, right? So whenever you are doing that subtraction or addition of M with A, that time consider that extra bit also, right? So both Q and M are positive integers represented using equal number of bits. One extra bit is considered to keep track of the sign of the result of subtraction, addition, whatever operation we are performing. So repeat the steps. So the algo is starting. Repeat these steps, not these steps. Repeat step number 1 n number of times. Repeat step number 1 n number of times. What is step 1? It is telling if the sign of A is 0, shift A and Q left and then subtract M from A. This we know. Otherwise, that means the sign bit of A is 1. Then what I need to do? I need to perform left shift and I will add M to A. Right? Now the algo is bit change, and why that change is there, we have seen. And then after the operation, if the sign of A is 0, set Q naught to 1, else set Q naught to 0. So see here that restoring part is not there. That extra operation is eliminated. Step 2. Step 2 says that you perform these steps how many times? N times. That means all the boxes in Q are now filled up. After your n number of steps, if the sign of A is 1, then add M back to A, right? This we need to do, because if at all we come up with a negative remainder, we need to add M to A so that we'll get a positive result, right? So now we'll see one example. Same operand I am taking 15 by 5. 15 is 4 ones, 5 is 101, equal number of bits, so it is 0. And whenever I am taking A, along with 40, one more 0 is taken to keep track of the sign of the result. So M will be also taken as 00101. One extra 0 is also there. And what is negative M? take the 2's complement of it. So it will be this one, right? So now my inputs are ready. Now we'll perform the operations. So what is the algo says? In the beginning, we'll see the sign bit of A. It is 0. So what we are supposed to do? Shift left and subtract. Shift left and subtract, right? So we'll do the shift left. So see, this is not for shifting, huh? This is my one of the operand only that we have kept. So shift left, we will do the shift left of A and Q. So 0001 and one box is created, right? Then what we'll do? We'll do subtraction. So subtraction will give me what? Here it is 4 zeros 1. Subtraction means add the 2's complement of 5. So I need to do this, right? So 1 plus 1 is 0. This is also 0. This is 1. So 1, 1, 1. 3, 1, 0, 0. See? 3, 1, 0, 0. Right? So when we see this result, what we'll do? We'll make our Q naught to be your 0. That's all only we need to do. No need to perform any restoring. Now you start the next cycle. What is the next cycle? Means what will be the next cycle that will be decided by this bit. So this bit is 1. So what I will do? Shift A and Q left and then add M. Right? This I need to understand. So shift left. I'll do that. So see, when I do the shift left, this one will come here and one more new box will be created. Already I have told in my previous video that whenever we perform a shift operation, vacated bit position is filled up by 0. But here, while using it for division, vacated bit positions will not be filled up by anything. We'll keep it like this only. And later on, depending on the sign of the result of your operation, if it is 1, it will be 0. If it is 0, it will be set 1. Like this, we used to go on, right? So shift left. We have done the shift left. Then what operation I'm going to do? I'm going to perform add, because when I start the cycle, that time the sign of A was 1. So shift left and then add. Add means 101. This 5, original 5, positive 5. So 11001 and then 00101 I need to add. So it will become 01111, right? Right. So see, we have done the addition and we have got 4 ones and 0. This together is the A's content, right? This is a sign bit. This is the magnitude bit, right? So 11110. So see, when this is 1, then this bit will be set to 0. So we have set it to 0. Now see, what will be our next step? Our next step will be, we need not have to do restoring. So this is 1. So what I'll do? I'll do shift left and add. Whenever the sign bit of A is 1, we'll perform shift and then addition. If it is 0, then shift and subtraction. So we will do it. Shift left. We have done. And one extra box is created, right? Now see, we'll do what? Addition operation. So see, 3101, addition means 101 I will add and it will be 00. So 1 plus 1, it is 2, so 1 carry. Then this is 2 ones, again 0, 1 carry, so 0. This one will be also 0, 1 carry, right? That will be discarded. So see, this 1 will be discarded. Now see, what is the sign of your A? 0 bit. This is 0, right? You can see this is 0. So if it is 0, this bit will be set to 1. That only I need to do. So we have done it. It is 1, right? Yet our operation is not over. Why? Because we need to have boxes in all the positions of Q. So yet one more is there. So see, next what I will do? Sign bit is 0. When sign bit is 0, next cycle will be left shift and your subtraction operation. So first we'll perform shift left. So this one will come here. So this is my bit pattern and here one new box is created. Now what operation I'm going to perform? Subtraction. So it is 00101. Subtract M means 11011. Actually this is 5 and this is minus 5. Anyways, I know I'm going to get 0. So 1 plus 1 is 0. Here 1 carry, so it is 0. 1 carry, so it is also 0. 1 carry, so it is 0. 1 carry, it is also 0. Last one is discarded. So this one is, see, this bit, right? And as the sign bit is your 0, this bit will be set to 1, right? So see here, this bit is set to 1. So now our operation is over. Our steps are over. Why? Because now see, in Q at every position one box is there. That means our result is ready. Where is your result? Result is in Q, that is the quotient bit. And where is the remainder? In A. So it is 0 only, right? So Q is 3 and your remainder is 0. And we know 15 divided by 5 will be 3 and remainder will be 0. So we have reached at a arrived at a correct result only. So see, this is very simple algo and very easy. Only you need to follow your steps carefully. What you need to remember is, whenever you are doing addition subtraction, then take as many bits as the number of bits in A plus 1. So this is A plus 1 is for that sign bit. So that many bits you take for M. So this how you keep your this divisor ready, so that subsequent operations will be correct only. Another bigger point, carry out of MSB addition should be discarded, right? And here no need to perform any restoring. That means if subtraction result is negative, then the next step will be left shift and addition. This is how you need to move. Hope this example is clear. The algo is clear. Both the algos are very, very important for doing division operation. Hope by these videos you have understood the integer division operation. And if you are getting from my explanations, then please do like my videos and subscribe to my channel. Thank you.